In this video, we are going to take a look at ISI MSQE 2023 PEB question number 5. Consider the following version of the solo growth model. The aggregate output is given by YT equals KT to the power alpha, LT to the power 1 minus alpha. Alpha is between 0 and 1. There is perfect competition in the factor market, so that in equilibrium, each factor is paid its marginal product. Okay, what does this mean? So we have two factors, capital and labor. Laborers earn wage rate, and in equilibrium this wage rate is equal to its marginal product, which means W is equal to MPL. And for capital we have rental rate, which is equal to MPK, and the total output is distributed to all the households in the form of wage earnings and interest earnings. Households save a proportion smallest of their disposable income. All household savings are invested. There is no depreciation. Population grows at rate M. Part A, the government taxes the interest earnings at the rate tau, which is between 0 and 1. Wage earnings are not taxed. Okay, only the interest earnings are taxed, but the wage earnings are not taxed. The government uses the collected taxes to fund government consumption. The tax collection is not used for investment. Okay. Derive with clear explanation the expression for aggregate wage earning, aggregate interest earning, aggregate savings, and okay. Let's try to do this. So first what I will do is I will find out the wage rate and rental rate. Okay. So wage rate is equal to MPL. What is MPL? It is partial differentiation of YT with respect to LT, right? So our YT is this. I will partially differentiate it now with respect to L. So I will get 1 minus alpha KT to the power LT, sorry, KT divided by LT to the power alpha, and I can write this as 1 minus alpha small KT to the power alpha. So small kt is nothing but per capita capital. So small kt is equal to KT to the KT divided by LT. This is our wage rate, and rental rate is equal to MPK, which is this. Now I will partially differentiate y with respect to KT. So I will have alpha KT to the power alpha minus 1 LT to the power 1 minus alpha. So alpha KT to the power alpha minus 1 divided by LT to the power alpha minus 1. So I'll have alpha small kt to the power alpha minus 1. Okay. So this is R. Now for aggregate wage earning, what I will do, I will multiply the wage rate with the total amount of laborers, which is W times LT. So W is nothing but 1 minus alpha KT divided by LT to the power alpha, and I will multiply this with LT. So I will have 1 minus alpha times KT to the power alpha and LT 1 minus alpha. I can write this as 1 minus alpha times YT. You can see that this is nothing but the total output. Now for aggregate interest earnings, what will be the answer? It will be R times KT minus R tau KT. Okay, because we need to give taxes on the entire earnings, so that is why I'm subtracting our total interest earnings, which is R times KT, and I'm subtracting that with R times tau times KT. Okay, so this will be R KT 1 minus tau, and R was equal to alpha KT to the power alpha minus 1 LT to the power 1 minus alpha and 1 minus tau. So okay, so there is another KT which I have not written here. So okay, first this, then kt, then 1 minus tau. Okay, so this will give me alpha. Again I will have yt here and 1 minus tau. Okay, because you can see that there will be kt to the power alpha minus 1, and since there is another kt, so I have alpha minus 1 plus 1, so I will have just alpha, and I from that I can get this yt. So this is our aggregate interest earnings. Now the aggregate savings, I need to find that out. Okay, so we know that the total output is distributed to all the households in the form of wage earnings and interest earnings, right? And out of this total income, the households are saving a proportion of S. So total household earnings will be equal to aggregate wage earnings plus aggregate interest earnings. So 1 minus alpha yt plus alpha 1 minus tau y. Okay, I can combine this and have this. Next, let's just open the term inside and I will have this. So 1 minus alpha times tau times yt. This is our total household earnings. So from this, our aggregate savings, which is st, is equal to small s times our household earnings. So this will be our aggregate savings. Okay, because from the total household earnings I am saving a proportion of small s. So this is aggregate savings. So the first part is done. Then define small kt, which is equal to kt divided by lt, capital labor ratio. Derive with a clear explanation the law of motion of capital labor ratio, that is the equation with small kt plus 1 on the left hand side and small kt on the right hand side. Okay, so for this, our law of motion of capital is capital kt plus 1 is equal to 1 minus delta times kt plus aggregate savings, which is, since we know that our total aggregate savings is equal to aggregate investment, so capital kt plus 1 is equal to this. Okay, since we know that there is no depreciation, so delta is 0, so I can write it like this: capital kt plus 1 is equal to kt plus s times this. Okay, now I know that uh, there is population growth. So what I will do, I will divide this by lt, lt and lt. Now for this I can do one thing. So I can write this equation like this as well. So first what I am doing, I am dividing both sides with LT. Then from that, I am on the left hand side, I am just multiplying and dividing by LT plus 1. So from here I can write LT plus 1 divided by LT times KT plus 1 divided by LT plus 1 equal to KT by LT plus S times this. Okay. This one will be 1 plus n. This is small kt plus 1 equal to small kt plus s times 1 minus alpha t, and this will be small yt. So this is output per capita. Why this is 1 plus n? Since we know that uh, our population is growing at a rate of n. So lt plus 1 will be 1 plus n times lt. So from here I am just writing this. Okay, so our law of motion of capital will be kt divided by 1 plus n plus s times y. This is our law of motion of capital. Okay, next will be the third one, which is derive with a clear explanation the steady state level of capital labor ratio in this economy and examine how K star changes with changes in the tax rate. Okay, first I need to find out steady state level. So in steady state, small kt plus 1 equal to small kt, right? So I can write it to be equal to k bar. Okay, now in the law of motion of capital equation, I will write k bar in place of kt plus 1 and kt. Okay, plus s1 minus alpha tau 1 plus n yt, and let's find out what yt is. So small yt is nothing but capital yt divided by lt, which is kt to the power alpha lt to the power 1 minus alpha divided by lt. So this is nothing but kt to the power alpha, right? So small yt is equal to kt, small kt to the power alpha. Let's erase this. Since I know that small yt is equal to small kt to the power alpha, since in steady state, I will write it like this, k bar to the power alpha. Okay, now I need to find out what k bar is. So for that, let's take these terms to the left. Okay, so this will be k bar to the power alpha. So k bar 1 plus n minus 1 divided by k bar to the power alpha is equal to this. Now I will have k bar 1 minus alpha, and there is n here. So this is equal to this. Now k bar to the power 1 minus alpha is this. So k bar is equal to s times 1 minus alpha tau divided by n 1 minus 1 divided by 1 minus alpha. So this is our steady state level of capital. Steady state level of capital. Capital per capita. Capital per capita. Okay. Now I need to figure out that what happens to k bar when tau increases. Okay. So from you have two ways to do this. Okay. Either you can differentiate k bar with respect to tau, or you can just check that when tau increases, the numerator falls because there is a minus sign here, right? Because tau rises, alpha tau rises, so 1 minus alpha tau will fall. So as a result, the numerator falls. So the entire term falls because of that. So when tau rises, k bar falls. So you can argue also like this, and we can conclude that there is an inverse relationship between the tax rate and steady state level of per capita capital. Okay. So now in part B, as in part A above, the government continues taxing interest earnings at the rate tau and wage earnings are not taxed. But consider now that the tax revenue collected is used to fund investment by the government so that the capital stock is further augmented by the public investment. Okay. So now for this, Derive with a clear explanation the expression for aggregate investment. Okay. Initially, in the previous question, our aggregate investment was equal to the aggregate savings which we found out, right? This was in the previous question, but now it will be aggregate investment will be equal to aggregate savings plus government investment. Okay, so our aggregate savings was equal to this, right? So let me write it here, is times this, and government investment is nothing but the entire tax. So what was the tax level? This was the entire tax. This is the entire tax collected. Okay, so r tau times kt, right? R kt is r tau times kt, right? Okay, let me write it here, r tau kt. So r was equal to alpha kt to the power alpha minus 1 lt to the power this tau kt, which is alpha tau, and this is plus 1, so yt. Okay, okay, this is our entire investment now. So keeping yt as constant, I will have this. Okay, so this is our total aggregate investment now. So for the second part, this is done. Now for the second part, derive with a clear explanation the new law of motion of capital labor ratio. Okay, so previously our law of motion of capital was this. Now I just need to change it a bit. Okay, let me write it here only. Okay, so kt plus 1 is equal to 1 minus delta times capital kt plus our entire aggregate investment, which is yt times s times 1 minus alpha tau plus alpha tau. Okay, this is the entire aggregate. This is the entire aggregate investment part. So from here, I just need to convert it once again. So I will do the necessary manipulations and I will get this from here times small yt. Okay, so this is our current law of motion of capital. So from here, part 3, which is derive the new steady state level of capital labor ratio in this economy K double star and compare it with K star. Does this comparison make economic sense? Okay, we need to find out K double star. Okay, so I made a small mistake here. This will not be K bar. Okay, this will be K star. Just go with the notation which ISI provides you. K star. Okay, so I need to find K double star. Okay, let's find that out. So in steady state, I will have kt plus 1 is equal to kt equal to k double star. So I will have 1 plus n k double star equals k double star plus s1 minus alpha tau plus alpha tau, and yt will be equal to, I know that yt is equal to kt to the power alpha, and I will just write this as k double star to the power alpha. Okay, so once again I will have uh, k double star 1 plus n minus 1, so just in k double star, and we have k double star to the power alpha is equal to this. Okay, now k double star to the power 1 minus alpha is times 1 minus alpha tau plus alpha tau divided by n, and I will just have this. This is my k double star. Okay, so if we compare this with the previous one, k star, you can see the numerator is now bigger. We have a plus alpha tau sign here, plus alpha tau term here, which is not present in k star. So you can clearly see that k double star is more than k star, and it makes perfect sense because the government is also investing now, right? So when investment rises, our steady state level investment rises, the steady state level of capital, per capita capital, so steady state level of per capita capital also rises, right? So this makes perfect sense. Now for the last part, how does k double star change with tau? Compare with the response of k star and explain the economic reason behind the differential impact. Okay, let's check this. So uh, here you can see that when tau rises, in this part you can see that the numerator will rise, but in the bracketed term you can see that it will go down. So there is a conflicting impact of tau. So what I need to do is I will just differentiate this with respect to tau. Okay, so I know that this is just a constant, so I will write it here. Then from that, let's just check what happens. So I'll have 1 by 1 minus alpha minus 1, and then I will differentiate the term inside. So s minus h is alpha tau, so minus s alpha plus alpha. Okay, so from here, so the power term will be 1 minus 1 plus alpha, so this will be alpha by this times alpha minus, so this is alpha times 1 minus s. Okay, so let's see what happens here. Okay, so when tau rises, let's do one thing. Let's just open up this bracketed term. This will be s alpha tau plus alpha tau, so s plus alpha tau times 1 minus s. Okay, so I have written this term inside the bracket here. Okay, now you can see that when tau rises, this term inside the bracket will also rise, right? Because there is a positive sign here and tau rises, so the numerator will also rise. So what is happening? The numerator is rising, right? So the numerator is basically positive. My bad. So when uh, this tau is positive, the entire term is positive. So this dk double star divided by dkt is strictly positive. Okay, I don't even, so another way of just doing this is I don't even need to do this complicated differentiation. So k double star is equal to, let me write this once again, plus alpha tau divided by n to the power 1 divided by 1 minus alpha, right? So I can write it like this: s minus s alpha tau plus alpha tau divided by n to the power 1 divided by 1 minus alpha, and from here s plus alpha tau times 1 minus s divided by n to the power 1 by 1 minus alpha. So this is k double star, right? So you can see that there is a plus sign here before the tau. So if tau rises, the numerator goes up, and as a result k double star will also go up, right? Since we know that s is also positive and 1 minus s will also be positive since s is between 0 and 1, so that is why there is a positive relation between tau and k double star. But previously in the part A we saw that when tau rose, k star fell. So you can see there is a difference between these two.